A very good morning to all of you. Today we are going to discuss on interrupt programming. So in the case of interrupt programming, the first step is to create a interrupt vector table. So while programming any of the interrupt, the programmer must either externally or through the program set the interrupt vector table for the type, preferably with the CS and IP address of the interrupt service routine. So we have already discussed in the previous class, interrupt vector table means it will store the address of the interrupt service routine that is associated with each of the interrupts. So for both hardware and software interrupt, vector table must be set either internally or externally by the programmer. The method of defining ISR for both hardware and software interrupts are same. So here we can see the transfer control during execution of an interrupt service routine. Here we can see that we are executing one program, so main program. So inside the main program we have a interrupt, that is int09h, that is the it's a software interrupt of type 09. So whenever we are executing this instruction, so we have to execute the corresponding interrupt service routine. So the address of the corresponding interrupt service routine is available in the interrupt vector. So we are assuming that the interrupt vector table is initialized suitably to point to the interrupt service routine. So we are transferring the control to the corresponding location. So the corresponding location we are fetching the procedure or interrupt service routine, and we will execute that procedure. We can see that ISR09H, there is a procedure. That procedure is corresponding to the program corresponding to that interrupt type. Then after executing that ISR, we have an end P. That means we are ending the procedure, and we will come back to the main program. We can see that after executing ISR09, the control will return back to the main program to the next instruction after IND09H. So then we can continue the execution of the main program. So here we can see that the main program, we have an interrupt instruction, that is IND0AH. So we will directly go to the interrupt vector table and fetch the address of this ISR and go to the particular location, and we will execute the ISR 0AH. And whenever we are executing this procedure, we have another interrupt, that is INT 0BH. So what will happen? So we will directly go to the interrupt vector table and fetch the address of this ISR corresponding to 0BH, and then we will execute that procedure. At the end of this ISR 0BH, we will come back to the ISR 0AH, that is to the next instruction after this IND 0BH. And after completing this ISR 0AH, we will come back to the main program, then to the next instruction, which is after IND0H, and we can continue the main program execution. So this is the transfer of control for nested interrupts. That means when we are executing one interrupt service routine, inside that procedure we have another interrupt request. Here we can see an example of an interrupt programming. So write a program to create a file result and store it in it 500H bytes from the memory block starting at 1000 to 1000 if either an interrupt occur at INTR pin with type 0H or an instruction equivalent to the above interrupt is executed. So here it is telling that we have to create a file named the result, and we need to write 500H bytes fetched from the memory location, that is code segment 100H with the displacement 100H, and write it into the file. So we have to, when we have to do this operation, whenever an interrupt request occurs, that means type 0AH interrupt occurs at the pin INTR pin. So whenever a type 0H coming to this INTR pin, so this operation to be executed. So it must occur while executing an interrupt 0AH. So whenever a zero AH occurs or a interrupt request coming through this INTR pin, that is in INT 0AH, then we have to create a file and we have to name it as result, and we have to fetch data from the code segment address 100H with the displacement 100H, and we have to fetch continuous 500H bytes from that location, and we have to write it on the file, name it as result. So this is the question. So here first here it is considering the data segment part. We can see that CS code and DS as data. So here we have to name the file as result. We are giving a name to the file as result, and we are giving another label, that is message, and it's assigned with the live file was not created successfully. So next we have to consider the code segment. Inside the code segment address is loaded into DS. Here we can see that move AX comma code, move DS comma AX. So this is the step for setting the IVT. That means the code segment address is loaded into DS. So first it is loaded into AX, then loaded into from AX to DS. So for writing a program for interrupt, we need to set the interrupt vector table first. So then next offset of the ISR of our interrupt, that is type 0AH, that should be moved to DX. So we can see that move DX comma offset ISR 0. So that means set DX at the offset of ISR 0H. So that means the offset of the ISR of the interrupt service routine of our interrupt type to 0AH is moved to the register DX. The function required for setting IVT is actually move AX comma 250AH, and then next instruction is INT 21. So then so this two instructions it will functions like a for setting the IVT, that is interrupt vector table. Then we have to move DX with the offset address of the result, that is file name. So we are setting a pointer to the file name. So now set DS with the code segment address for the result file. So here we can see that the date move AX comma data and move DS comma AX. That means set the DS at data for file name. So then we are clearing our count register, that is CX, that is move CX comma 00H, means we are clearing the CX register. Then we can see move AH comma 3CH and INT 21H. So that is for creating the file, create file with the file name result. So here we can see JNC further. That means now jump not carry. That means if the file is created successfully. If no carry means create operation is successful. So if in JNC means jump not carry. So if jump not carry means if we are performing this two lines, that is move comma 3CH and INT 21H. So if we are doing this doing these lines for creating a file with a file name result, and if there is no carry in that, then we will jump to further. You can see there is a further label. The corresponding that there is a IND 0H is there. So IND 0H means the corresponding interrupt will be executed. So that means there is no carry. If there is no carry means file creation is successful. And if carry is set, if the carry is set, then that means the file was not created successfully. So we have to display the message file creation what was not successful. So for first we can discuss that the if the carry is set. So carry is set means move dx comma object message. So we have already declared a variable that is message. So we are moving the address of that message to the location dx. Then move ah comma 09h. So then then int 21h. So that will display the message. So the message we are stored in the label message. That means file creation was not successful. First we have to load the dx with the object value of the message, which will display the message pointed by the message label. Then we can directly jump to stop condition. You can see that JMP stop means we are directly jump to stop condition. That is an unconditional jump. Then stop label indicates that that means you can see at the stop label you can see that OH comma 4CH INT 21H. That means write into it and return to DOS prompt. That means stop the main program and transfer control to the DOS prompt. Now we can see if there is no carry. That means in JNC further if there is no carry means it will jump into further label. Okay. So the further label you can see that int0h, that means the corresponding interrupt will be executed. So that means the file is successfully created and we are executing int0h. When we are executing this int0h, what will happen? It is actually point to the ISR of 0h, ISR corresponding to 0h. So if the file is created successfully, then the control of the program that will directly go to the ISR of 0ah. So here we can see that we can see that the procedure corresponding to this ISR 0A 0H. So that means if when we are writing the program of a interrupt table, the first step is to we have created the IVT. So we are already created the IVT. So from that location we will get the the address of this ISR 0H and we will execute that procedure. So both the ISR and the program code present in the same segment. So here we can see that BX is loaded with a file pointer that is BX comma AX. So take the file handler in BX, then move CX comma 500H. That means that we are copying the count variable because we have to move the data. That means 500H bytes of data, 500H bytes of data from that location and move. We have to move to this. We have to write the data into the file. So we are setting the count as 500H and then move dx comma 100H, that is already specified in the question. That is we have a code segment that is 100H and with the offset value 100H, that is moved to AX. So the offset of the block in dx and the segment value of block in ds. That means that AX is moved to ds. Then we have to write this data into the file. For that we are executing two instructions, that is move ah comma 40h and int 21h. So what will happen? That is a function for writing into the file. So file is pointed by the ds register. So file is actually pointed by the ds register where the data will be entered. So after the writing the file, we have to return back to the main program. So with that we can see that I return. So it will stop the execution of the procedure and it will return back. So then the stop level that indicates the end of the program. So this is the in the program for interrupt programming. Thank you.